Hi, in this lesson we are going to be talking about some of the basic operations on matrices. The first one that we are going to be looking at is what we call the scalar operation. Okay, so what is a scalar operation? Okay, so that is basically multiplying a matrix with a constant. Okay, so if I have A, okay, and I multiply A with a constant K, so the result of that would be KA. Okay, so if K is 2, if K is 2, that means the result of KA would be 2A. Okay, so let me give you an example over here. So if the matrix A is given as 4, 8, minus 1, minus 3, minus 2, and 0. Okay, so as you can see, this is a matrix which has 2 rows and 3 columns, 2 by 3. And I'm going to multiply A by a scalar or a constant, which is 2. So 2A. So in this case, what would happen is all the elements in matrix A would be multiplied by 2. Okay, so I will have 4 times 2 minus 3 times 2, 8 times 2 minus 2 times 2 minus 1 times 2, and 0 times 2. Okay, now with that we can complete this multiplication here. So 8, 16, minus 2, minus 6, minus 4, and 0. Okay, so 2A is equals to this matrix over here. All right, now with the scalar, with the understanding from scalar, we can now move on to another very basic operation on matrices, which refers to the addition and subtraction. Okay, now for addition and subtraction, okay, there is an important condition, okay, that we have to take note of, that both of the matrices, okay, both of the matrices must have the same dimension. Okay, must have the same dimension. Then only you can do the addition or subtraction. Okay, when I say same dimension, I'm referring to the size. That means the m by n. That is what I'm referring to here. Okay, let's look at an example. Okay, so I have an array A equals to 1, 2, 3, 4, and I have another array B which is 5, 6, 7, 8, and what I want to compute is A plus B. Okay, now firstly we can check and confirm that both of them have the same dimension. Okay, so this is also a 2, this is a 2 by 2 matrix. B is also a 2 by 2 matrix. So when we do A plus B, what we get is the element, okay, in each position will add to the corresponding element in the same position from the other matrix. Okay, so if you remember the positioning or the labeling, we refer to the first element here as A11. Okay, in this case here, since this is B, we can refer to this as B11. Okay, so the number in position 11, which is row 1 column 1, will add with the number in the position row 1 column 1 from the other matrix. Okay, so what I will have is 1 plus 5. Okay, similarly the second element over here, so if I were to label, this is A12 and this is B12, row 1 column 2. So I will have 2, plus 6. Okay, similarly you have 3 plus 7 over here and 4 plus 8. Okay, and then your final answer would be 6, 8, 10 and 12. Okay, so that is the final answer for this addition operation here. Okay, now let's look at an example, another example here. Okay, so in this example, A is given by this matrix 3, 1, 2, 2, 1, 4. Okay, and B is given by this matrix here 1, 0, 2, minus 1, 3, 0. And I want, or let's go and calculate A plus B. Okay, so when you calculate A plus B, what do we get? So we can see that both of these matrices have the same dimension. This is a 2 by 3 matrix, 2 rows and 3 columns. Similarly, B is also a 2 by 3 matrix, 2 rows and 3 columns. Okay, so the first element here, 3 will add with 1, so I get 3 plus 1 here, then 1 plus 0, then 2 plus 2. Then over here I have 2 plus negative 1, 1 plus 3 and 4 plus 0. Okay, and we can now complete the addition. So 3 plus 1 is 4, 1 plus 0 is 1, 2 plus 2 is 4, 2 plus minus 1. So plus times minus will give you minus. So 2 minus 1 is 1, 1 plus 3 is 4 and 4. Okay, so that is the final answer here. Now, how about computing A minus B? Okay, so A minus B, you follow the same principle as A plus B in a sense that the elements are exactly the same, except that now instead of doing the addition operation, we are going to be doing the subtraction operation. Okay, so what I'll have here is 3 minus 1, then 1 minus 0, 2 minus 2, 2 minus minus 1, 1 minus 3 and 4 minus 0. Okay, and that will bring us to 3 minus 1 is 2, 1 minus 0 is 1, 2 minus 2 is 0, 2 minus minus 1. So minus and minus will be plus, so 2 plus 1 is 3, 1 minus 3 is minus 2 and 4 minus 0 is 4. So that is the final answer over here. Okay, now there are some rules with addition and subtraction that can make our analysis a bit easier at times. So the first rule is commutative rule, which basically says that A plus B is the same as B plus A. Okay, they are both the same. The second rule is associative rule, which says that if I'm adding or if I'm doing arithmetic operations for more than 2 arrays, so A plus B plus C for example, okay, so I can do 2 at a time first. So if I do A plus B and then I add C, the answer would be the same as me doing A plus B plus C. The answer would have been the same if I did B plus C first and then I add with A. Okay, so these are the two rules that can help us in our addition and subtraction of matrices. Okay, with that we have covered the basic concepts of matrices in terms of scaling, addition and subtraction. Please do check out the questions on my website so that you have some good practice on these concepts. And once you are confident with this, you can go on to my next lesson on matrix multiplication. Alright, so do check out all those videos on my website. Thank you. Bye.